students, this is Miss Roll. In today's video, we are going to go over ions and isotopes, with our objective being to understand both of these concepts. So these are some of those variations to what an atom is that we've talked about or I've alluded to in the past videos. So we're going to start getting into what those changes and variations can look like. So I hope you have that notes sheet opened up. You can fill in the blank, or you can be taking notes however you choose if you'd like it to do it a different way. So first of all, can an atom be different? Protons never change. So our protons for an atom do not change if it's the same atom, right? Any atom of carbon is going to have 6 protons. That just kind of is a fact. Those are not what are going to vary between different kinds of a particular element. Because those protons define what the element is. The neutrons and the electrons are things that can change. Particularly during the PhET simulation from last week, you might have noticed talking about the charge and whether or not it's an ion. So that was when our electrons could possibly change. So these variations are when it stays the same element, but it's slightly different. So the picture that you see down there are some examples of isotopes. And like I mentioned in the PhET, you've seen some examples of ions. So we're going to go on to identify or define what these two different things are, and then get into some practice with drawing those Bohr models of different ions and isotopes. So first of all, what are isotopes? This is when neutrons are different. Neutrons, those remember are in the nucleus of the atom, and they don't have a charge, so they don't affect the overall charge of the atom. But what they do change is the mass. So the Bohr model stays the same. It looks basically the same, except a different number of neutrons are written in the middle. It's the same element. It pretty much has the same characteristics, except it has a different mass. This can affect things like radioactivity and things like that. So you might have heard the term isotopes if you ever read anything about radioactivity. But for the purposes of our class, we just need to know that it gives the atom a different mass. Ions are when the electrons are different. So the ion, the word ion, means a charged atom. So remember we said that our atoms we were building before were neutral. They had the same number of protons and electrons. Now that number is going to be different. Our number of electrons are going to be different. We've been dealing with only neutral atoms so far. To become charged, it loses or gains an electron. Loses or gains an electron. So you always start off thinking about the atom with that same number of protons and electrons, and then based on our charge is when we start thinking about it changing. So when an atom loses electrons, it becomes positive, and when it gains electrons, it becomes negative. This is one of those things that gets a little bit harder to think about because we oftentimes thinking about adding things as positive and taking away as negative. But our electrons are negatively charged particles. And because they are negative charges, if you get more of the negative charges, it becomes negative. So we have to remember that when we lose electrons, it's positive. And when we gain electrons, it is negative. So valence electrons is another vocabulary term that you're going to hear us talking about, and they will become the most important thing when we start talking about bonds in our next unit. So valence electrons just mean the electrons in the outside shell or energy level. Okay, the ones on the outside. The reason these are most important is because these are the electrons that would be doing any bonding with different atoms. Atoms want to be happy. This is the way that we talk about why atoms are causing reactions. And happy means that they have a full shell. So they either want to give up electrons or take electrons to be happy. And this is where we get into that why it would form an ion. So you will hear us talking about valence electrons, talking about the electrons in that outside shell. And those are the ones that are going to be either gained or lost to cause an ion. So let's do a little bit of practice, since that's the best way for us to understand. So here I have our fluorine atom. So we're going to start off with just drawing our neutral atom. That's always the best way for us to start, so we know what the base is, and then we can start thinking about how it changes to cause a charge. So first of all here, we need to write our protons and neutrons in the center. We know that our protons is this top number, or our atomic number. So I'm going to go ahead and write in that we have 9 protons. Oops, clicked the wrong button. There we go, 9 protons. And to get neutrons, if you remember, we round the atomic mass, which is on the bottom of our periodic table square. And then we subtract from it our atomic number. So we have 19 minus 9 gave us 10 neutrons. I'm going to go ahead and type that in our box for the ion as well, since we know that with our ion, our protons and neutrons are not changing. So it's going to be the same number of protons and neutrons. Now we get to look at those electrons. So our neutral atom, again, just like we've done last week, has the same number of electrons as our as protons. So we know that we had 9 protons, meaning we're going to have 9 electrons. I'm going to go ahead and put 2 in the first ring, and then I need to draw another 7. So I got 3, 4, 5, 6, 7, 8, 9 electrons total. So in that neutral atom there, and I kind of spaced them out like we were talking about last week, I have 7 in the second ring, so that'd be 7 valence electrons right now. Now in that second picture, we're going to take a look at its charge, finding out the charge of fluorine. All right, so here we have our charge of -1. So again, we have to think back to a negative charge tells us we have more negatives. And since it's a 1, that means we're going to have 1 extra electron. So I had 2 in my first ring. That's going to stay the same as last time. And I had 7 in my second ring. And we know that we're going to be adding an electron. So I'm going to end up with a full outside ring. Or in other words, I'm going to end up with one of those happy atoms that I mentioned before. Because all of our atoms are looking to have a full outside shell. So because I said our charge was -1, that means we're going to have 1 more electron in our ion than we did in the original. And so now I have 8 electrons in the outside shell, 2 in the middle, for a total of 10, which is our fluorine atom with a -1 charge. Go on to our second example here. So we are going to talk about sodium. So noticing here, sodium has 11 for its atomic number. That will also tell us then our number of protons. So I'm going to go ahead and write that in the center of our Bohr model. We have 11 protons. And then our neutrons, remember, comes from taking that atomic mass on the bottom of our periodic table square, rounding it to get our mass number. So here I have 22.990. And when we round that, the number after the decimal is higher than 5. So we're going to round it up to 23. And 23 minus 11 gives us 12 neutrons. And again, our protons and our neutrons do not change for our ions. So we can write them in both the neutral atom and the ion Bohr model. Now we're going to go ahead and start talking about those electrons. So in our neutral atom, we have 11 electrons. We know it's going to be the same as our number of protons. I'm going to go ahead and put our first 2 electrons in our inner shell, which we know only fits 2. So now I'm going to go on to the next one. Our second shell can fit up to 8 electrons, and 8 plus 2 only gives us 10. So I know that that second shell is going to be a full shell of electrons. So I'm going to go ahead and put those in our second shell here to see how many we need to do after that. And again, I'm going around in a circle, kind of putting them on as if there were 4 sides, and then giving them a partner. we will talk more about forming the ions yourself next week or in the future here, so you can take a look at that. So now we have our second ring filled with 8 electrons. So we have 10 total drawn right now, and we need 11 for this sodium atom. So I'm going to put our last electron in that third energy level. Okay, that's our neutral atom. Now if we look over towards the side that says ion, it has a +1 charge. And if we remember, a positive charge means that it has fewer electrons because it has less that are negative. And so because it's +1, we're only going to lose 1 electron. So I'm still going to have my 2 electrons in that first shell, and then a full second shell, right, with that full 8. And I know what they look like, so I'm just going to put them all next to their buddy. And then we're not going to have that 1 lonely electron in the outside shell. And that's because our atom, again, wants to be happy, and atoms are happy with a full outside shell or a full shell of valence electrons. And the easiest way for that sodium atom to do it was to lose the 1 outside electron. And so our sodium ion looks, actually, if we look back, exactly like our fluorine ion, but they are different elements because they have a different number of protons. And their charges are different because they had different elements that they were starting on. So we're going to go ahead and go on to, whoops, didn't mean to click that. Go on to our last example here. We're going to talk through a phosphorus ion. So again, we start by taking a look at the top of our square. It has 15 for its atomic number, which tells us that our number of protons is also 15. Again, this is the same in both the neutral atom and our ion. And then when we start talking about the neutrons, we take that bottom number, our atomic mass, and round it. 30.974, we're going to round to 31. That would be our mass number, and then we'll subtract our atomic number. So 31 minus 15 is going to give us 16. So we have 16 neutrons in both our neutral atom, 16, and in our ion. All right, now we get to draw our electrons. So again, it's the same as our atomic number. So we're going to have 15 electrons. I'm going to start by putting 2 electrons in our first shell because it only fits 2, and we know they're going to go there. So I've got 2 in the first shell. Our second shell can fit 8 electrons, and that would give us a total of 10. And since I need 15, I know that it's going to be a full shell. So we'll talk about what the third shell looks like here, but I'm just going to fill our second shell with those 8 electrons. And remember, we kind of imagine as if there were 4 sides, to our atom, and we have pairs of electrons on each of those sides, right? They want their friend to be with. So now I've got 8 in the second shell, 2 in the first shell for a total of 10. I need 15. So now I'm going to start going to that third shell and add another 5. 3, 4, and 5. So now when we look at this neutral atom, you'll notice that 3 of our electrons in that outside shell have no partner. There's no buddy next to them right now. Those 3 electrons want somebody to hang out with. They want another electron. And so that's what's going to cause a reaction or cause this ion to form. So I'm going to go ahead and pause the video and put the electrons on our ion, and we'll talk about how we got there. And there is our phosphorus ion with all 20 of its electrons. So you'll notice that those 3 lonely electrons that we pointed out in our neutral atom now have a partner next to them, and that's with our -3 charge. So remember, when we get a more negative, that means we have more electrons. So I added 3 more electrons to give those lonely electrons a partner, and now we have a full outside shell, a full valence energy level. And that is our phosphorus ion. So now you can go on to do the practice on your own. Please let me or Ms. Abbott or Mr. F know if you have any questions, and good luck with ions and isotopes.